In the first video of this subject, we said something and moved on quickly. We said that to fix a new point, you measure from two references, and that one way is a perpendicular offset from a line. Today, we find out what that means with a chain in your hands, and here is what makes this topic worth your attention. Take a 15-meter offset and let your direction be out by just 3 degrees. You would barely see it. That mistake moves your plotted point about 0.0785 centimeters along the chain line, but only 0.002 centimeters away from it, nearly 38 times. Same mistake, two completely different consequences. By the end of this video, you will be able to prove that in 2 lines. Unit 2 is called Measurement of Horizontal Distance. Notice the word horizontal. Every plan you draw is a horizontal projection. So whatever the ground does, the number you write down must be a horizontal distance. There are several ways to get it. Pacing gives roughly 1 in 100, an odometer 1 in 200, a rangefinder 1 in 50, tachyometry 1 in 500, and at the top electronic distance measurement. But the two at the center of this unit are chaining and taping. A tested chain gives about 1 in 1,000, a steel band 1 in 2,000. That is the working accuracy of ordinary survey. In metric work, you meet two chains, 20 meter and 30 meter. The 20 meter chain has 100 links. The 30 meter chain has 150, and in both one link is exactly the same, 0.2 meters. Now, how do you read a chain without counting 100 links? By the tallies, a tally sits at every 5 meters, a brass ring at every 1 meter, and the tallies are toothed. One tooth means 5 meters from the nearest handle. 2 teeth 10, 3 teeth 15 from the nearest handle. That is what lets the system work from either end. So on a 20-meter chain, the central tally at 10 meters has 2 teeth. On a 30-meter chain, the center is 15 meters, so its central tally has 3. One more thing, a chain stretches with use, so it is tested against a gauge. Permissible error is plus or minus 5 millimeters on a 20-meter chain, plus or minus 8 on a 30. Learn those two numbers. 4 tapes, and you must tell them apart. The linen tape for offsets and ordinary work. The metallic tape, that same linen reinforced with brass or copper wire, and this is the one commonly used for all survey work. The steel tape, read this carefully because it is a favorite question. The steel tape is not normally used in the field, it is used for standardizing chains. And the invar tape, an alloy of 64% steel and 36% nickel. Its thermal coefficient is very low, so temperature barely changes its length, and it goes where precision matters most. Triangulation, the work of the Survey of India. Around the chain sits a small kit, and every piece has exactly one job. Arrows mark the end of each chain length on the ground. Wooden pegs mark a survey station, something more permanent. Ranging rods mark the direction of a line. The plumb bob hangs vertical by gravity, projecting a point up to the tape or down to the ground. Remember it because it returns when we chain on a slope, and the line ranger, two prisms, one above the other with silvered diagonals. Its advantage is practical. It needs only one person to range a line. Before you lay a single chain length, you range the line. Ranging is establishing intermediate points on a straight line between two endpoints, and it must be done before the line is chained. Range first, chain second. There are two kinds, and telling them apart is a guaranteed mark. Direct ranging is used when the end stations are intervisible. The surveyor stands about 2 meters behind the rod at A, looks towards B, and directs an assistant until the 3 rods coincide and appear as a single rod. That is the test, not roughly in line. A single rod reciprocal ranging is used when the end stations are not intervisible, usually because of high ground between them. 2 chainmen stand near the line, each able to see the other and one far station. The man at R directs the man at S into line. Then the man at S directs the man at R. They alternate, each correcting the other, and converge until both stand on the line AB. That is why it is called reciprocal. Neither of them can see the answer. Together they walk into it. 2 assistants do the chaining, and you need both by name and by duty. The chainman at the forward end is the leader. He drags the chain forward with the arrows and a ranging rod, fixes an arrow at the end of every chain, and obeys the follower. The chainman at the rear end, holding the zero end at the station, is the follower. He directs the leader while ranging, carries the rear handle, and picks up the arrows. Notice the arrangement. The leader is in front, but the follower is in charge because only the follower, standing at a fixed station, can see whether the leader is on the line. And now the neat part. The leader starts with 10 arrows. Each chain length he plants one, and the follower picks it up. When the leader has none left, all 10 are in the follower's hand, and that means exactly 10 chain lengths have been measured. That handover is how the count is kept. Here is the problem. This unit is really about lay a chain on a slope and it measures the slope, but the plan needs the horizontal distance. For a short, steep slope, use stepping. Measure in short horizontal steps, each end drop to the ground with a plumb bob. The horizontal distance is simply the sum of the steps, no trigonometry at all because you measured horizontally in the first place. For a long, gentle slope, measure the slope angle theta with a clinometer, measure the sloping distance L, and the horizontal distance D equals L cos theta. And there is a third way, the cleverest, because it fixes the problem in the field instead of on paper. The hypotenusal allowance. Stretch the chain along the slope. Instead of driving the arrow at the end of the chain, advance it further down to a point chosen so that one stretched chain length stands for one chain length horizontally. How much further? A B is 100 sec theta and a prime B is 100 links, so the extra piece is 100 into bracket sec theta minus 1. In links, add that at every chain and the total you have booked is already horizontal, nothing to correct afterwards. So how do you survey a whole field with nothing but a chain? Here is the key idea. In chain surveying, you measure no angles at all, only lengths. And a triangle is the only figure that can be plotted from the lengths of its sides alone. So the whole area must be covered with a network of triangles. That network has names. Main stations are taken along the boundary, and the lines joining them are the main survey lines. Subsidiary stations sit on a main line to divide the area or pick up interior detail. Tie stations are subsidiary stations whose joining lines are called tie lines. The base line is the most important line of the survey. Generally, it is the longest. It runs through fairly level ground. It is measured very carefully and its magnetic bearing fixes the north line of your map. Everything else is built on it, which is exactly why it gets the most care. The check line joins the apex of a triangle to a fixed point on its base. You measure it on the ground, you scale it off your plot, and if the two agree the triangle is right, if they do not, you have found your mistake before it spreads. Not every triangle will do, and the reason is geometry, not fussiness. A triangle is well conditioned when no angle is less than 30 degrees and none is greater than 120. The equilateral triangle is the ideal. 60, 80, 40 is acceptable, but 25, 20, 135 is ill-conditioned, and it is not used in chain surveying. Why does it matter? Think about how you plot that apex. You set your compasses to the two measured sides and swing two arcs from the ends of the base. Where they cross is your point. In a well-conditioned triangle, the arcs cross squarely and the crossing is a sharp little cross. You can put a pencil point on it. In an ill-conditioned triangle, the arcs run nearly parallel. Where they meet, they graze. Instead of a crossing, you get a long, thin smear, and you cannot say where along it the point belongs. A tiny slip moves the plotted point a long way. So the rule is not arbitrary. Between 30 and 120 degrees, your arcs cross cleanly. Outside it, they do not. Now, the thing we opened with an offset is the lateral measurement taken from an object to the chain line. It is how every fence, hedge, road and building gets onto your plan. A perpendicular offset is taken at right angles to the chain line. Note the chainage at the foot of the perpendicular and the offset length. Two numbers and the point is fixed. An oblique offset is any offset that is not perpendicular used when the object is far from the line or a right angle cannot be set up. Take 2 points on the chain line. Note both chainages, measure the two distances to the corner, plot that triangle, and its apex gives you the corner. Perpendicular offsets are preferred and the syllabus wants 4 reasons. They are quick, The survey is not hampered, the field book entry is easy, and the plotting is easy. How long may an offset be? Never longer than your tape and generally limited to about 15 meters, but it also depends on the accuracy wanted, the scale of the map, the nature of the ground, and the maximum allowable deflection of the offset from its true direction. Hold on to that last one, it is about to become the whole point. A perpendicular offset needs a right angle, and there are 4 accepted ways to set one out. Swinging the tape where the minimum reading is the foot of the perpendicular. The 3-4-5 triangle using nothing but the chain, a builder's square. And the cross staff or optical square. The open cross staff is 4 metal arms with vertical slits. The 2 pairs at right angles on a pole 1.5 meters long. Hold it vertical on the chain line, sight the ranging rods through one pair of slits and the object through the other, and move along the line until both are bisected at the same time. And then the optical square, more accurate and the instrument of choice for long offsets. A small circular metal box with 2 mirrors inside. The index glass is completely silvered, the horizon glass is silvered on its upper half only and clear on the lower half. And the 2 mirrors are fixed at 45 degrees to each other. Here is the principle, and it is the loveliest idea in this topic. When a ray is reflected twice, the angle between the first incident ray and the last reflected ray is twice the angle between the mirrors. Twice. So mirrors at 45 degrees give a sight at exactly 90. See what that means. Through the clear lower half, you see the ranging rod directly. In the silvered upper half, you see the object brought round by 2 reflections. When those 2 images sit exactly one above the other, the line to the object is at 90 degrees to the line to the rod, and you are standing on the foot of the perpendicular. The mirrors are built in and cannot move, so the instrument cannot go out of square. That is not luck, that is the design. Now we can settle the question we opened with. Set it up carefully. The offset should have gone out perpendicular to the chain line. Call that true direction A to D, but you laid it out slightly off along A to B at an angle alpha. Your tape reading was correct, the length is right, only the direction is wrong. So where does the plotted point land? Drop a perpendicular from B onto the true direction and call the foot C. 2 errors come out of that little triangle. BC, which is L sin alpha, that displacement runs parallel to the chain line, and CD, which is L into bracket 1 minus cos alpha. That one runs perpendicular to the chain line. To put either on paper rather than on the ground, divide by the number of meters that 1 centimeter represents. First standard question, an offset is laid out 5 degrees from its true direction. The scale is 20 meters to 1 centimeter and the displacement on paper must not exceed 0.03 centimeters. Find the maximum length of offset. The ground displacement is L sine 5 degrees, on paper L sine 5 degrees divided by 20. Set that equal to 0.03. So L is 0.6 divided by 0.087156. L is 6.884 meters. Look at that answer. A 5-degree error means your offset may not exceed about 6.9 meters, less than half the 15-meter limit we quoted earlier. That is the 4th factor doing its work. Second question. The offset is 15 meters, the scale is 10 meters to 1 centimeter, and it is laid out 3 degrees off. Find the displacement of the plotted point perpendicular to the chain line and then parallel to it. Perpendicular, first 15 into bracket 1 minus cos 3 degrees is 0.02055 meters on the ground. Divide by 10, 0.002 centimeters on paper. Now parallel. 15 sin 3 degrees is 0.785 meters on the ground. Divide by 10, 0.0785 centimeters on paper. There it is, 0.0785 against 0.002, about 38 times larger from the very same 3-degree mistake, and now the reason is obvious. Getting the direction of an offset wrong slides your point sideways along the chain line. It hardly changes how far out from the line the point sits. Your object ends up in the right place across the plan and the wrong place along it. which is exactly why the syllabus asks about degree of offset and error in offset, and exactly why a long offset is set out with an optical square and never by eye. The record goes in a double-line field book, with 2 lines ruled down the middle of every page. The chainage is entered between those lines. Offsets and detail are sketched left and right, on the side they actually lie, and you begin each line at the bottom of the page and work upward. Why? Because you walk forward as you chain, so the page grows the way the survey line does. Choose your stations before any measuring begins. They must be intervisible, they must form well-conditioned triangles, the baseline must be the longest, each main triangle should have at least one check line, and obstacles to ranging and chaining should simply be avoided. Let us gather it up. Range first, chain second, direct when the ends are intervisible, reciprocal when they are not. 20-meter chain, 100 links, 30-meter chain, 150. One link is not 0.2 meters in both. Leader in front with the arrows, follower at the rear in charge. 10 arrows in hand means 10 chain lengths measured on a slope, step it out, or D equals L cos theta, or add the hypotenusal allowance and finish with nothing to correct. Baseline the longest and most careful, check line to prove the triangle, and no angle below 30 degrees or above 120, so your arcs cross cleanly. Offsets perpendicular by preference, limited to about 15 meters. And the direction matters far more than you would guess, because L sin alpha is very much bigger than L into 1 minus cos alpha. And the optical square, where 2 mirrors at 45 degrees give a sight at 90 by design and not by luck. Next video we finish Unit 2 with Part B, the systematic errors in chaining and their corrections, obstacles in chaining, and finding the area of a field by chain and cross-staff survey. The study notes are on the Telegram channel, free as always, and the link is in the description. Keep it simple, keep it clear. See you in the next one.